See how we do this. Okay, so today we will take a look at, scroll back to the top. All right, text processing and regular expressions. I think this is really exciting. So we'll try this out. Okay. So first things first, you got to we're going to be using Stringer as the package to parse our text. Okay, and if you master regular expressions, you can, the whole world of text processing opens up to you. And so anyway, install library Stringer, and we'll use that, okay? And in Stringer, we've got a series of functions, okay? We've got string detect, string locate, string extract, string match, and string split. Okay, and all of these functions work in the way of we give it a string and then we give it a pattern. Okay, the string is the text that you want to process. So it could be the text of the US Constitution. It could be the text of someone's tweet. It could be the text of a web page. It could be the text of whatever it is that you're looking at. And then you will give the function a pattern and say, do you see this pattern? The pattern could be anything as simple as a word, and you can say, like, how many times is the word president mentioned in a bunch of tweets or something like that? Or how many times is you can say, you can give it a pattern such as a literal word or a literal phrase, like if you were analyzing Twitter data, you could see how you can give it the pattern of someone's username, right? And try to get some information on how often you see this username appear. Okay, or the pattern could be a kind of a pattern. So in Twitter, if you want to mention other users, you type in the @ sign. And you would type in their name, right? And Twitter handles, you can't have a space in there. You can have an underscore and stuff, but you can't have a space. And so you can try to find, you can say, I want to find anybody who's mentioned. And then so you would tell the function to search for the @ sign followed by some characters. And then that would be detected, okay? And so you could give it patterns, or you could say, we're looking for phone numbers, and phone numbers are, usually three digits followed by 3 digits followed by 4 digits, and you can give it a pattern that way and say, I want you to find anything. So we don't need you to find this exact number of 310-555-1234, but we want you to find, maybe you want to say, I want to find any number with a 310 area code, and just say 310 followed by 3 digits followed by 4 digits, and you can specify kind of a little bit more of a generic pattern that way. Okay, all of the functions have the string text that you want to process followed by a pattern, and we have string detect, which just means did you find this in there, right? So if we give it the Constitution and we give it the pattern, the literal pattern, we the people, and we say, do you find the phrase we the people in there? It will say yes, right? And if we say string locate, it will say, we the people, we found it starting at, the first letter of I guess, I don't know, maybe it says preamble, so maybe it would be like the 9th letter or something. And we the people, however, and then it'll say it ended at the, 15th letter or something like that, Okay, so first letter to the 12th letter or something like that, or 15th, I guess, with spaces there, I don't know, whatever, something like that. Okay, so that would be string locate. It gives you the first position with the kind of the start and end. String extract pulls out the pattern that matches. If you give it a literal pattern like we the people, it will just pull out we the people. But if you say find something where it says @ and in Twitter data you give it @ followed by characters, then it will pull out, at, the Ellen Show, or at Real Donald Trump, or whatever, some username, something like that, okay? So that would be extract. String match will pull out, you can establish what's called a capture group. So within the pattern that you've given it, you might say, you know what, we're looking for area code, phone numbers of 310 area code, but I'm not interested in 310, okay? I know all of these things are gonna be 310. I'm just interested in the prefix, the 3 digits followed by the 4 digits. We just want that 3-digit part. You can establish a capture group using the parentheses and just say, I want to pull out just this portion here, okay? And that's what string match would do. String split then, splits up the original text that you give it into different chunks and pieces. That's what we have, okay? All right, so to get a handle on this, for the pattern part, we got to learn regular expressions, okay? And there we had a little comic here. I'll let you guys read this. It's only kind of funny, but it is when you manage and master regular expressions, you do feel like you can swing in like a hero and save the day. It does suddenly, when you get a handle on it, you feel like, man, I can chop through any chunk of text and look for what I need to find. Okay. Let's see. So simple matching. This is just giving it a literal string, and we want to find this exact string. Okay. So here, this text is a vector of text. So these functions work on vectors, but they'll also work on, later on I will have everything just in one string, okay? So here I'm giving it a vector of words, the words being the quick brown fox jumps over the lazy dog, and now we're gonna say, okay, search over that vector, string detect, look over that vector of words and see if you find the pattern Q-U-I-C-K, all right? And it says, okay, in this first word, do I find Q-U-I-C-K? Nope, false, okay? Do I find Q-U-I-C-K here? Yes, true, and everywhere else, false, okay? Then we can also just say, all right, do you find the letter O? All right, and this first word, no, it's not there. Quick, no. Brown, yes, the letter O is there, and the word fox, it's there. Over and dog, it's in there. The other words, it's false. Or you can give it, kind of a partial thing. Do you find the pattern R-O-W? And it will find R-O-W in the word brown. Okay. These are string detect. String detect. So here we have this. Okay. If I did string locate, you'll see what happens. Okay. String locate, it will say, as far as the letter O goes, it found it, as far in the third entry, it found it in position 3, and it started and ended at position 3, which makes sense because the pattern here is only one character long, right? But then if we did string detect ROW, then it would only, and we did locate, it would say, okay, it starts at the second letter in the word brown and ends at the fourth letter in the word brown. So that's string locate. The real power of regular expressions comes with these meta characters. Okay, these are the meta characters. Basically, your bracketing symbols, parentheses, square brackets, curly brace. Okay, also the dot and the star, the plus, the question mark. Also the caret and dollar sign, and then these slashes for kind of the or sign. Okay, so this is how we make regular expressions powerful with meta characters. And so if you are searching for the literal meta character, you have to escape it with a backslash. Okay, the only problem is that the backslash itself is a meta character, so you have to give it a double backslash. Okay, so here, if we say, do you detect square bracket in here, okay, and we just give it the square bracket, this regular expression sees this as the meta character square bracket and not the literal square bracket. So it's going to say, I can't find this thing. If you say / square bracket, this tells the regular expression that we are looking for the literal square bracket. Does the square bracket exist in here? Then it will say yes. It has detected it. Okay, and again, because this / itself is an escape character, it needs to be escaped. Okay, so the first kind of set of meta characters that we use are called anchors. And anchors say we'll find matching based on the position of the word, okay? Position of the pattern. So this says in the pattern, this will only work if it's at the very start of the string or if it's at the very end of the string. And you can use the caret or the $ to indicate that. Or you can use /A and /Z, okay? We also have word boundaries, and we've got little b for if it's a word boundary, and if it's not a word boundary, we use the capital B. So I'll show you some classes of characters later, but a lot of times in regular expressions, the thing that, if there's a certain class of thing, to match it, you would use the lowercase letter, and to not match it, to match the opposite of that thing, you use the capital letter. Okay. Yes?
What is a word boundary? Is it like a period?
Yeah, so word boundary, so in English, we use spaces to distinguish the start of one word from another, right? So if you see baseball with no spaces, then we know that's the sport of baseball. But if you see base space ball, then we know we've got two different nouns, base and ball. And so boundaries are just basically spaces or things to indicate that a word has begun, right? So over here, we can take a look at this. So now my string is now I just have one string, and it's the quick brown fox jumps over the lazy dog. Okay, so let's take a look at this. Okay, so here's my string. The quick brown fox jumps over the lazy dog. And here I'm going to say, search this text, string replace, search this text, and see if you find at the start of the string the capital letter T, then followed by H, then followed by E. Is it going to find that there? Yes, because the string starts with that word, that pattern, and so it will replace that pattern with a dash. Okay. If, on the other hand, let's say I get rid of the capital T here, and I say, at the start of the string, do you find H and E? Will this work? No. This says, I didn't find a match, so I didn't replace anything with anything here. Okay. Over here, I've got, at the start of this string, do you find the word DOG, or the letters, the pattern DOG? And what will that return? It's not going to find a match, so it will return the original string there. Okay. At the end of the string, do you see capital T, H, and E ending the string? No, that's going to return back the original string. Do we find DOG ending the string? Yes. So DOG at the end of the string gets replaced with a dash there. Okay. It's case sensitive. So if I replace it with this will not match anything. Okay. And if in the text I put in a space here, I have the text is space, the quick brown fox jumps over the lazy dog. Okay. This doesn't work either, okay? It's at this. I would have to say at the start of the string we need to have a space, and then that will work. Okay, so it's as people we would probably say these things are the same, but for the computer they are not. Okay, so now that I've gotten rid of the space and I've gotten rid of the space here, this will match. All right, is that okay? The anchors. Okay, let's, if instead of using the caret to indicate the start of a string, we could use the / capital A. This is exactly the same as this one, these two. So you can use / capital A. So these two text and the caret the and / capital A the, these two are exactly the same. So they produce the same results. Or you can do / z for the end of the string. This is the same as this thing right here. Okay, so these two are the same. So $sign or /z, those are equivalent as far as regular expressions go. Okay. Here we have examples of word boundaries. Okay, so again, if we take a look at our text, this is what we have. With the word boundary, this means it has to be at the start of a word. Do we see JUMPS and then that ends the word? So basically, do we find the word jumps as a word all by itself in here? And the answer is yes. Okay, it finds jumps at as a word in its entirety there. Let me just kind of put this here. And then, oops. But over here, this one, I've got at the beginning word boundary, JUMP, and we have to have a word boundary, basically a space after P, but it's not a, we don't want to match the space, we just want to match the word boundary. Is this going to find a match here? This will not, okay? This will not, because there's an S, and that's not a word boundary. That's still part of the word. So the regular expression does not match. If I get rid of this, will this match? If I get rid of the word boundary at the end of jump, so I got / B, jump, the end of that. What will it leave? So when I run that, it replaces JUMP and it leaves me with the S. It leaves me with the S there. Okay. Here, if I have a capital B, this means not a word boundary. So this is going to match. Do we have the letters UMP basically in the middle of a word? Okay, not at the boundary. So this will match, okay? So it says J, and it replaced the UMP in the middle of a word, okay? Over here I've got this. Here, if let me just throw in the word UMP in here. Okay, so if this is my text here, what will this replace this line, 102, non-word boundary, UMP, non-word boundary. Will this replace the UMP over here? It will not, because UMP here is has word boundaries there, okay? So this will only match this. Whereas if I just do this, word boundary, UMP, word boundary, this will replace the last one there. Okay. And then if we don't bother with that and we just have UMP without any kind of word boundary indicators, then that works for both. Okay. And then this one will not work because J is at a word boundary, so that doesn't replace anything. Is that okay? The kind of the usage of anchors and word boundaries. Okay, so word boundaries, the /b is basically there's a space in front of it, or it starts a right here. There's no space in front of the, but it recognizes it as a word boundary, right? Because it says that's the end of the word there. Okay, so those are examples of anchors. Now we have classes of characters, okay? So here we've got little s for white space, big S for non-white space, all right? So, and white space includes both breaking and non-breaking spaces. Are you guys familiar with non-breaking spaces? Not really? Okay, so in so when you type something into Word, okay, the computer forms breaks between words, right? So as you are typing, if I say, you know, today I ate a banana for breakfast, it realizes like, oh, I cannot fit the word for after banana when I reach the end of the line. So it pushes for down onto the next thing, right? And then so here's an example where I've got Los Angeles, and it says, okay, you've typed in LOS, and then I'm not going to be able to fit Angeles onto the same line, so we're going to put Angeles onto the next line, right? But someone might say, you know what, Los Angeles, it's really important that those two words stay together. When you split up the two things, it doesn't feel like that represents the noun, okay? And so what we can do is we can say, you know what, we want to see it like this, but we want the space there, but I don't want these two words to end up on separate lines. You enter a non-breaking space. In Word, you do this by doing Control-Shift space, okay? And this puts in a space here. And so it looks like they're two words. They are two words, but Word now recognizes that we cannot, no matter how hard we try, we cannot force the two words apart, right? As soon as the word doesn't fit, it pushes the whole thing down onto the next thing, right? Whereas if it were just a regular old space, it would put them on two separate lines, okay? So that's a non-breaking space, and with the hidden characters, we can see it has a different symbol than the regular spaces there. Okay. But anyway, so that's a non-breaking space, but it still counts as white space, and that's going to be /s. When you do your scraping of baseball team names, I think the baseball team names have non-breaking spaces. So when it's like the Arizona Diamondbacks, like there's a non-breaking space between Arizona and Diamondbacks. And so to do your text processing, I provided some code in there to go through and replace all the non-breaking spaces with regular spaces so that it works. Okay, but that's what we have. Okay, so white space is a little s, not white space is capital S. Digits, so 0 through 9, little d. Capital D is anything that's not a digit. Little w is for word characters, basically all the letters, digits, and underscores, and anything that's not that is going to be a capital W. We can also specify ranges of characters using the dot for any character other than a new line, and then brackets for all of this. Here, let me just kind of demonstrate some of this stuff here. So here, if we do, let's take a look at our text. The quick brown fox jumps over the lazy dog, and let's say we're going to just replace the letter O. Okay, this will go through. Oh, and here for string replace, it just replaces the first one. I'm going to do string replace all. Okay, so this will replace every time it finds an O, it goes through and it replaces it with a dash. Okay, here I can do O // W. // W is a word character, so basically a letter. And so this will replace the letter O followed by a letter. And so what will it return? It will return BR, and it will replace the O and W. And then it will also replace the O and X in fox, the O and V in over, and the O and G in dog. Okay, so that's what we get, okay? brown F. Looks like we're swearing a little bit, but that, you know, that's what it does. Okay, so that's how we got /W. If I do E//W, what will this replace? What will this match? ER and over. Okay, that will match ER and over. If I do capital W for not a word character, what will this get? Yeah, it'll say E and then the space in the, and the E and the space over here in the. Okay. /d, it will not replace anything. Capital D, non-digit, it will take over the ER and over, the E space in the, and the E space over here. Okay. Or you can do E and S for space, and it does the, and then E and capital S for non-white space, and it gets rid of the ER and over. Okay. Are these examples okay? E followed by digit, E followed by non-digit, E followed by word, or E followed by non-word, and E followed by space or non-space. Okay, so that's what we have there. We can also give it ranges of characters. So rather than just saying E followed by a word or letter, we can say, you know what? I only want to replace O followed by X or G. So what will this get rid of? The OX in fox and the OG in dog. Okay, so this will get rid of the quick brown F, jumps over the lazy D, and that's what we have, right? So here it just says match, and when we have the bracket, this basically says just this is like a single character. It's not X and G. It treats these as kind of single patterns. So it says O followed by X or O followed by G. So that's with the square brackets. If you put a caret in there, this means not these characters. So square bracket. So here, if I did O caret XG, what will this get rid of then? It will get rid of O followed by a non-XG in brown, and O and followed by a non-XG in over. That's what we have here. If I did E followed by non-R, then it will replace the E space, and then if I say E followed by R, then it will get the over. Okay, and you can do the same with digits. So these are, you specify ranges this way. When you have a bracket, what will this get? String replace text, and we have bracket THE. What will the resulting thing be? Will it replace this one with a capital THE? Will it replace anything in there? It will. It replaces the H and the E in the capital THE, okay? And then it replaces the TH and E in the, and it also replaces the E in over, okay? Because here it just says, go through this string and see if you can find anything that matches TH and E, and so it does. And so having the letters here, it's treated basically as a bag of letters. And so THE and EHT, these are exactly equivalent. These are gonna give you the same thing, because it just sees these as letters, and it doesn't see it as the word the, it sees them as the letters E, H, and T, and do we match this, and we're telling it to replace them all, so it's gonna just go through and do that. Okay. And if we wanted to get the capital 1, we could throw in the capital T in there, and then we'll replace that as well. What if I do this? It'll replace everything except the Z in lazy, right? Oh, and the capital T. So there we go, all right? Here we have quantifiers, right? So earlier we did a pattern like O followed by a word character, okay? And so it said O followed by W for brown, ox and OV in over, okay? We can specify quantifiers. Here this means the star means match 0 or more, the plus means match 1 or more, and the question mark means match 0 or 1. Or you can specify exactly how many with curly braces. You can say I want exactly 3, or I want exactly 3 or more, or a range 3 to 5 or something like that. So here we saw O followed by 1 word character. What is this? O followed by W plus / W plus. This would be 1 or more word characters. Okay, O followed by 1 or more word characters. So what will this return? This will match OWN in brown. So it matches the O followed by 1 or more word characters, so it would get the WN. And then it would match the entire word over because that's O followed by the letters VER, okay? And it still matches fox and dog, the OX and the OG in fox and dog, okay? So this is O followed by 1 or more word characters. Okay. If like if I throw in the word whammo here, okay, and then I say string replace O followed by 1 or more word characters, will that match the O in whammo? It will not, because the plus says we need to have 1 or more. Okay. However, if instead of the W I put in a star, then it does. Then it matches the O there. Okay, because it says I matched the O and then I had 0 word characters after that, but that still counts as a match. Okay, W star / W star would be 0 or more, right? If I didn't put in /W, but I put in a dot, and I did dot plus, okay? The dot is any character except new line. Any character except new line. So what will this return? Well, it'll match the O in brown, and then it will match every character after that. So this will return the quick BR. Okay. So the dot is a little bit dangerous, okay, because it's going to match everything. So the reason why the W's, the /W stopped is because space is not a word character. Right? So it matched anything that's a letter or a number, but it didn't match anything. Non-word characters there, okay? So those are quantifiers. Let me see what else we can kind of mess around with. Okay, with a question mark, if I do /W question mark, this says we've got to match an O followed by 0 or 1 word characters. Okay, the question mark is 0 or 1 word characters. So what will we get? So the original text is the quick brown fox jumps over the lazy dog whammo. All right. What will it match in brown? It will match OW in brown because it's 1 or more. Okay. In fox, it matches OX. In over, it matches OV because it's 0 or 1, so it's going to match the 1. And then whammo, it matches the O, and it says, well, I didn't find any, so I matches 0. Okay, so if it can match 1, it'll match 1. And if it can't, it'll say it's okay. That's what the question mark means there. What if I had E? So again, the original text is the quick brown fox jumps over the lazy dog whammo. And I have E here. E followed by word character question mark. So 1 or more, 0 or 1 word characters. What will we get? It'll replace all the E's, right? It'll get rid of the E in the, it'll get rid of the ER in over, and the E in this the. Okay. We have something called greedy versus ungreedy matching, all right? So if you use a star for 0 or more, it's going to be go greedy, okay? And then if you pair, if you have a dot star, which is kind of like match everything, it's going to try to match as much as it can. So here I've got, you know, like some HTML tags here, and we give it the pattern. Okay, find this opening div tag. So the greater than, less than sign, those are not meta characters, so it's going to match these without any kind of problems here. And then the / is also not a meta character, so it doesn't provide any problems. Just the dot and the star are meta characters. And so here it's going to look for this pattern, you know, less than div greater than, okay, so basically an opening div tag here, and it will find this as a match. Okay, so it's going to start there. Dot star says everything after that until you find this kind of closing pattern here. And it finds the closing pattern here, and it finds the closing pattern here. So with dot star, it's going to try to get as much as it possibly can, and so it's going to match the last case that it does. And so that's what it returns. You put in a dot star question mark. The question mark makes it ungreedy, and it's going to try to end as early as it can, which is going to be right here. Okay, so it's going to only return this div tag and not this one. Let's try it right here. Okay, so if I do O dot star O. Okay, so we're going to replace O dot star O. So we've got the quick brown fox jumps over the lazy dog whammo, and now we're going to look for the pattern. It starts with O, then any character until you find another O. Okay, if I run it like this with greedy matching, it's going to find this O in brown, and then it's going to go as far as it possibly can, and it's going to find the O here in whammo, and it's going to replace everything there. Okay. If I put in a question mark after my star, then it will go ungreedy. All right, so here's my text, the quick brown fox. So here what it will do is it's going to go O, and it's going to go up to this O. So it will replace from this O to this O, and it will go BR-X, okay? And because I'm doing string replace all, it's going to continue on, and it's going to go, oh, here is over, an O here, and it's going to continue on until it gets to this dog, and we'll replace that with a dash. So it'll go jumps and then dash G, and then it finds the O here, but then that's the end of the string, so it doesn't find a closing thing to match. So here, that's what we get. Okay, so the ungreedy puts a hold on it and says, you know what, don't be so ambitious with replacing everything. Just when you can end the match as early as possible, end the match there and do that. Is that all right? That's ungreedy. Okay. There's something called groups. With groups, you put parentheses around kind of the portion of the pattern that you want to pull out or separate. Okay. So what we can do is, if I did a string match, okay, with match, I don't give it this argument, okay? And we can give it this pattern. And so this is greedy, and so it's going to go from the O in brown to the O in whammo. And here, it says, you know what? I know I'm starting with the O and I'm ending with an O. I just want what's between the O's. We put in a parentheses here. And what this does is it takes out the entire word, the entire pattern that matches, and then it just returns what has matched inside the parentheses. Okay, now that maybe this feels weird, okay? And there could be kind of questions like, why would we do this? So this is just the part that we want to match. We could, you know, if we wanted to, we could say I want between O and O, let's get 3 characters followed by 4 characters followed, and I'm going to set in, here, let's just do dot star, okay? So this will go from O to O, and here inside the capture group, I just said, give me kind of your first 3 characters here. What is this going to do? All right, let's take a look at the original text. We've got the quick brown fox jumps over the lazy dog whammo. Here, it says return back the first 3 characters, and so it returns back, it sees the O and it gives me a W, N, and space. Okay. Let's make this ungreedy. Here, we'll just do 2 here. And if I do this ungreedy, then over here it goes from O to O here, and it will pull out the first 2 letters after the O. The dot 2 in curly braces will say just the first 2 letters that comes after the O. And because that's in the capture group, it separates that out. Over here, it matches over the lazy do, and it's going to match just the first 2 letters after the O here, and so it pulls out a VE. Let's say I want to go from an E to an O, okay? So if I do from the E to the O, and I say, give me the first 2, that's what we get. We get space Q and ER, and you know, we could set up 2 capture groups here, all right? And so notice it says E, I don't know if this is getting too crazy now, but basically the pattern that we're trying to match starts at E, will end with O, and it says we want kind of the first 2 letters that come after E, then we'll allow for anything in between, and then we want the 2 letters that come before the O. All right, so if we look at the text, it's going to find E to an O, all right? So it goes from here to here, and so the first 2 letters after the E will be space Q, and then the last 2 letters before the O will be BR, okay? And then it tries to find it again, and it sees, okay, from over the lazy dog, it's going to give me the first 2 letters after the E, which is an R space, and then gives me the last 2 letters before the O, or the last 2 characters, which will be a space D. Okay, and that's established using the parentheses to establish capture groups or matching groups. So, and the dots just kind of are like everything. So this allows me to match both the letters and the spaces. Okay, and so that's how we can use groups. And so here's some just simple examples of groups where we have characters A through J, and we got A, parentheses B, C, and D. So the extract will match the entire pattern. The match will take the entire pattern and then also return just what's inside those capture groups that you've established. Here's an example with some phone numbers. So here I've got some text. I got the word Apple. Phone numbers where the person used spaces. Phone number where the person used dashes. And somebody here provided 2 phone numbers and wrote work and home and gave me colons and semicolons and dots and dashes. And for our phone pattern, we can say, okay, we're going to establish a capture group using the parentheses. And then we say it's going to start with the digit between 2 through 9, because no area code will start with a 0 or 1. So we can say any digit between 2 through 9, followed by any digit 0 through 9, and we want 2 of those. So that will match things like 219, 329, 579, so on and so forth. This will match the literal dash or actually really any character. So it will take that, and this will also match any character. This says, any digit 3 and then any digit 4, and we've established capture groups. So when we do the extract, it pulls out kind of our first match. If we did extract all, it pulls out multiple matches, because in the last case it's going to find 2 matches and it pulls them both out. Whereas the regular extract, it just pulls out 1. With extract all, it's going to return it in list form and say I found both matches here. And then if we did match, it will return back what it found and then pull out those capture groups. So it pulls out the 579, the 499, and the 7527 here in the capture group. And with match all, it starts off, it gives us in list form, and because it had 2 in the last one, it returns each of those as part of what it matched there. Okay. I strongly encourage you to kind of check out these resources. This one right here, Test Regular Expressions at regexer. This one's really great. Here you don't use double backslash, you just use single slashes, but you say, all right, well, how do I find something? What if I want to find like the literal dot, the literal dot followed by any kind of word characters after that, and it will say, okay, it found .demo.com. Here, if you put parentheses around it, okay, then you can hover over it, and it will say, all right, I matched .demo, but the group that is going to be extracted is DEMO for demo, okay? And so regexer, this is a good place, and so you can kind of just, if you're having trouble with, so you're gonna have to do some regular expression stuff for the baseball thing, and you can kind of just paste in some of that text here and just kind of play around to see if you can find a pattern that works. Okay, we'll end here for today, and I hope you guys have a great weekend, and we'll see you guys on Monday.